Hello class. We are now going to do section 8.5, which is about the binomial theorem. But before we get into that, there's some preliminary stuff we have to do. So the first thing is a new definition. So that is n with an exclamation point after it. And what that means is n is some whole number, and that is called the factorial symbol. Factorial. So you can look how that's spelled. Look up how that's spelled in your book. And what it means is it means multiplication. So for instance, if I have 5 factorial, that means I start at 5 and multiply down times 4, times 3, times 2, times 1. And I multiply those numbers together, and the answer, which is 120, I believe, is 120. So factorial is a shorthand way of writing multiplication in a particular way. It's multiplication from some whole number down to 1. Okay? Next, we've got something called a binomial coefficient, and there is space on your handout for you to write this definition down. Okay, so let me write down. I have an n and an r, and there's big parentheses around them, like that. This is not a fraction. There's no fraction bar between the n and r. Please don't put one there. And again, this is a definition. This is notation that means use this formula. And the formula is n factorial over r factorial, and then n minus r factorial. Okay? This formula is something for something called the binomial coefficient. A lot of times you're going to hear your math teachers say n choose r because of how this formula works in probability. Now we're not going to do probability in this class, so I just would like you to memorize this formula, okay? And let's use it because all those letters are kind of confusing. So to use it, I am actually going to go ahead and do, the first problem off of your handout. So I'm going to do it on this piece of paper though because I need more space. So if you look at your handout, problem number 1 is 12 choose 8. Remember we say 12 choose 8. Okay, so what does the formula say? The formula says the top number is 12, so that's n factorial or 12 factorial on top. The bottom number is 8, so that goes in the bottom. 8 factorial goes in the bottom. And then the difference between 12 and 8. So 12 minus 8 is 4. 4 factorial. Okay? So the top number is on top, the bottom number is on bottom, and the difference between the two is also on the bottom. They all have factorials. Now you can get out your calculator. Your calculator does have this factorial button on it. But I'm going to show you the short and easy way to do it. So remember, 12 factorial means I'm going to start at 12 and go down. 12 times 11 times 10 times 9 times 8. I'm going to stop there. And I know I could continue, right? I could go times 7 times 6 times 5 all the way down to 1. But if I did that, I could shorten it up by putting an 8 factorial. So I want you to think about that. Okay, so you can hit pause and think about why that's okay. Maybe write it all up and then squish it back down on your own. The bottom I'm going to leave 8 factorial times 4 factorial. And now look, since I've used that shorthand of 8 factorial on top, it matches the factor of 8 factorial on the bottom, so those cancel. Okay? So now my next step will be, scoot it up a little bit, equals 12 times 11 times 10 times 9 over, now let's expand that 4 factorial. So that's 4 times 3 times 2 times 1. And now you just cancel stuff out. So let's see. 12 is the same as 4 times 3. What else can I do here? 2 will go into 10 5 times. And now I just multiply what I've got on top. I've got 11 times 5 times 9. 11 times 5 times 9, which is 45 times 11, which is, I have no idea what. I will let you guys, wait, I'll cheat. 495 it says. I have the answer key. So that is, whoops, you can't see that, can you? That is problem number 1 off of your 8.5 handout. So I would like you guys to do problems number 2 and problem number 3. Now, in order to do problem number 3, you need another piece of information. Now, this is a definition. Remember, definition means you just have to memorize it and go with it. Don't think about it too much. There's a good reason for this definition. You can ask me in class. 0 factorial does not equal 0. 0 factorial equals 1. 0 factorial equals 1. Okay? Memorize it. That is a definition. You're going to need that to do number 3. All right. Now we're going to look at something called Pascal's triangle. And this is a triangle built of numbers that has a pattern. And it turns out that the numbers in Pascal's triangle correspond to particular binomial coefficients, which is what we're going to need when we do the binomial theorem. So let's start. You always start your triangle at the top with just a plain 1. And now we're going to build our triangle. On this side will go 1, on this side will go 1. Okay? Now, the third row, see the first row had 1 number, the second row had 2 numbers, the third row is going to have 3 numbers. And the way you build it is you always start with 1. To get this number, you're going to add the 2 that are above it. So that will be 2. And then it always ends with 1. Okay? The fourth number will have, the fourth row will have 4 numbers. Again, you always start with 1. To get the next one, we look at the 2 above it. So 1 and 2 is 3. 2 plus 1 is 3. Ends with 1. Let's do the next row. 1, 4, 6, 4, 1. Let's do a couple more rows just for fun. Let's see. 1, 5, 10, 10, 5, 1. Let's do one more. 1, 6, 15, 20, 15, 6, 1. Now you could go all day once you understand the pattern. So I want you to go back, if it didn't make sense the first time, start over and look at the pattern for Pascal's triangle. I also want you to notice that Pascal's triangle has this nice symmetry. Remember, symmetry means mirror image. So it goes 1, 6, 15, 20, and then back down 15, 6, 1. 1, 5, 10, back down 10, 5, 1. So notice that. That's interesting. All right.